Forensic anthropology is going to be our last topic we discuss in forensics for this year. So what is forensic anthropology? Basically, when forensic scientists use skeletal anatomy and skeletal remains to identify human beings. So some things that the human bones can reveal are gender of a person, male versus female, any pre-existing injuries or diseases that the person may have had in their lifetime, the approximate age of the person, their approximate height, and their general health and well-being. Anthropometry is related to anthropology. However, it's specifically when you distinguish one individual from another based on a series of bodily measurements. So this was the very first system of personal identification, and this occurred before fingerprinting became a personal identification method. So Alfonso Bertillon, who in about 1879 came up with this idea of anthropometry, we call him the father of criminal identification because he used a series of measurements, as you can see in the picture, the width of your head, the length of your arm span, the circumference of your head, the length of your foot. There's many different types of measurements he conducted. And putting them all together, he determined that you could generalize a person's height and things like gender based on just their measurements. The problem is, if you don't have a full skeletal system found and you just have certain types of remains, it makes it a little bit more challenging. But he did have this first personal identification system, which was then replaced by fingerprinting. So as far as the adult human being, on average, you have about 206 bones in your skeletal body. The average male's skeletal remains weighs about 12 pounds, and the average female's skeletal remains weigh about 10 pounds. And that doesn't include any fat, organs, skin, it's just the bones. Infants, however, have a lot more bones, 450 on average, because a lot of things when they are born are not fused, and then as they grow, they fuse together to form one larger bone, which decreases the number. So when skeletal remains are found, there are several important questions that a forensic scientist needs to have answered. The first question is, what was the age of the person at the time of their death? So they're very important. This is a very important question because if you have a missing person and it's someone who's much older or much younger, you know it cannot be that person. So specific bones or body parts that determine or help determine person's age at the time of death. Mandible development, which is the lower jaw area. You can see in this picture birth, 3 years old, 6, fully grown adult, and then elderly. So you can see the mandible grows and develops over time. With that, you also have more teeth if the teeth are intact, and then as you age, you start to deteriorate. Skull suture marks can also determine age. So younger children and babies and infants don't have a fully fused skull, which is why they say babies have a soft spot, whereas adults have a fused skull. Growth changes in the tibia, so that's in your leg. Children sometimes go through growth spurts, and we say they have growing pains. It's actually true because your tibia is expanding. And as I said, just the amount of teeth and which teeth are present. Some teeth come in earlier in life, some come in later in life, like wisdom teeth, so that can be a determination. Here's just another general chart showing you different parts of the body and what they can tell you based on their appearance. And this will help you generalize age based on these specific body parts and their appearances. You can also determine the gender of a person. The most clear evidence comes from the skull and the pelvic bone. So a female skull, if it's on the right here, it's relatively smaller in circumference and lighter. And the muscular attachments are thinner, and it's much more severely angled than the males, which is almost a 90-degree angle. And you have much smaller muscle attachment locations compared to the males, which are much more prominent. And as far as the female skull, it's also a lot more rounded, whereas the males kind of juts back more. So the frontal bone is also higher right here and rounded more. This almost goes backwards almost immediately, where the females goes up a little bit and then starts to round. And as I said, the jaw of a female is much more acute than a 90-degree angle compared to the males. And once again, the pelvis bone, the pelvic bone is also super important. Females' pelvic bones are obviously wider in diameter across to be able to encompass a child and childbirth. The tailbone is also shorter compared to the males, once again, to make room for childbirth and to make sure that there's enough room for that child to be birthed without anything being in the way. And the subpubic angle is also larger. So this angle is much larger than the males because, once again, it has to accompany childbirth. So this is a more accurate diagram. So you can see the males is very triangular. The females is much more open and rounded. And then actually looking at the pelvic bone from above, the males is not as wide and the tailbone comes down much longer, where in the females it's much wider with a much shorter tailbone. So that's a very clear indicator of gender, along with the skull. You can also determine race, but how this is usually with a skull. It's hard to determine race with other bodily parts. So the main three race groups we like to characterize are African, Asian/Native American, and then European. So European is the Caucasian, Asian and Native American, that's clear cut, and then African would be of Black descent. So different things you can see both in this chart and located over here. I like to look at this pictorial. So it says Caucasians have a longer and narrower face. So the chin is longer and narrower, and then the orbitals are rounded ovals, and that's just slightly angular. And then the nasal passage is narrow and with a prominent chin. Native Americans and people of Asian descent usually have a wider side of the face area, the cheekbone area. They usually have a somewhat pointed skull feature, just slightly. The skull is usually shorter in length in general, and the orbitals are very rounded. And then African American ancestry is also long skull, but notice it's almost a slant on the skull, not as rounded as the Caucasian, and this is even still rounded with a slight point. And usually the nasal area is a little bit wider. So like I said, 3 general races. If you are of mixed race, though, that could potentially complicate things depending on what is prominent from each type of ethnicity. And then the person's height can also be generalized with some specific bones like the femur, tibia and fibia, humerus, radius, ulna bones. So those are going to be the main bones in your arms and legs. That can determine a person's height, which can also generalize a person's age. So in the lab you're going to be looking at various ulna bones from the arm to determine height. And there's an algorithm or an equation that you plug in the ulna or whatever bone's length from males on average and then females. And it's pretty accurate. So like I said, very quick topic, but anthropology is super important if you have skeletal remains. And based on the type of skeletal remains that are found, you can determine things about the person like age, gender, height, race, things like that.